Any questions? Okay, so let's proceed. So this is part 2 of your module on diodes, where we're going to take up practical diode applications. We're actually only going to take up 2 types of circuits. So these are your rectifier circuits and your clipper, or what we call your limiter circuits. Itong dalawa lang, no? You're going to take up many more diode circuits in your future courses. The inputs to these circuits are not necessarily DC inputs. In fact, more often than not, they are time varying inputs. And what we're going to do is we're going to show the functionality of these circuits using AC input voltages. In this case, sinusoidal input voltages. But that does not mean that these circuits can only be used with sinusoidal input voltages. As long as you have a time varying, or actually any type of input, you can use on these particular circuits. So you should be able to get the output of these circuits for any type of input. We're going to start with the half-wave rectifier. And we're going to use the ideal diode model to analyze this particular circuit. So the input waveform, itong Vin, is drawn here. This is the sinusoidal input waveform Vn. Okay, so let's proceed to analyze this circuit. Okay, so how am I going to analyze this circuit? What is my first step? Well, gamitin natin yung method 1. No? So using method 1, I assume that the diode is conducting. Therefore, it is equivalent to a short. No? Equivalent to a short circuit. Bakit siya short circuit? Dahil ang ginagamit natin is yung ideal diode model. No? That's why it's equivalent to a short circuit. So let me draw it here. No? Ito ngayon yung diode ko. No? This is my diode. Okay. Now, how do we know whether the model is correct? No? The model is correct if we find that current is flowing in the clockwise direction. Then we know that the model is correct. Okay. We're going to analyze the circuit, okay, using, well, there are two parts of the input. Ano? The input has two parts. This is what you call a cycle. Okay, and these are your half cycles. Okay. So we're going to analyze the circuit taking into consideration the positive half cycles, so these half cycles, and the negative half cycles. Okay, take note that during the positive half cycle, the current I, okay, let's say this is I, is positive, no? Or clockwise. Okay, what does that mean? If I is positive or clockwise, that means current is flowing from anode to cathode, or current is flowing along the direction of the diode arrow. And therefore, tama itong equivalent circuit natin. Kung tama yung equivalent circuit natin, ano yung value ng Vout? What is Vout? Can I hear a shout out, please? Ano yung magiging value ng Vout?
Sir, yung Vin po minus yung voltage across the diode.
Yeah, pero ang equivalent circuit natin ng diode is a short eh. So ano
Ay, edi
yung
sir, Vin lang din po.
okay, so V out is just V in, no? So that is during the positive half cycle. Okay? So if I plot V out here, it's equal to V in, ito magiging V out ko. Okay, now during the negative half cycle, so ito ngayon yung mga negative half cycles, ano? Ito nasa baba. Okay, I is going to be in the opposite direction, no? I will be counterclockwise. No? Your current will tend to flow in the opposite direction. In other words, kukontra siya dito sa diode. If that is the case, then diode is an open circuit. So diode is equivalent to an open circuit. If the diode is equivalent to an open circuit, ano yung value ng V out? Can I hear someone else tell me what the value of V out will be?
0 po, sir.
Bakit 0? Tama yung sagot, no? But I just want to hear why it is 0 for everybody to know also.
Kasi po open po yung circuit, so wala pong complete path. So wala pong current na dadali sa resistor, wala pong voltage drop.
Very good, no? Exactly the answer that I was looking for, no? So, open yung circuit, so I is equal to 0, therefore wala kang pwedeng maging voltage drop across your resistor, so V out is equal to 0. So during the negative half cycle, output natin ganyan yung itsura. Okay? So you can see now the relationship between the input and the output, assuming that the diode is ideal. Now this is what you call a half-wave rectifier. Now what do you mean by a rectifier? No? A rectifier, by definition, converts from AC to DC. Converts from AC to DC. Hindi ko alam kung naalala niyo pa yung kinuha natin nung first week nitong course na to. But how do you define AC? You define AC as the polarity of the voltage changes or the direction of current changes in a periodic manner. So pag tinignan natin yung Vin, no, nagbabago yung polarity ng voltage in a periodic manner, no? Kasi dito positive siya, dito negative. Dito positive yung voltage, dito negative yung voltage. Pag tinignan natin yung output, while nagbabago yung value ng V, hindi nagbabago yung polarity. The polarity always stays positive, no? That's why, theoretically speaking, this is already considered to be DC. Hindi na yan AC. It is not constant DC, but it is DC because the polarity of the voltage does not change. Para maging AC siya, kailangan nagbabago yung polarity in a periodic manner. So again, no, this is DC. It is not a constant DC, but it is DC. And ang usapan natin, if I don't specify, if I say DC, then the understanding is constant DC. No? So this is a time-varying DC. So that is your half-wave rectifier. Now what if I had assumed the constant voltage drop model? So the constant voltage drop model. Ngayon, let's try to work out our analysis using method 2, no? This time using the open circuit voltage. So kanina ang ginamit natin yung method 1, you replace it with its equivalent circuit assuming it is conducting. Now let's use the method 2 or using the open circuit voltage. So this is, let me call this V of D. So when will the diode conduct? No? The diode will conduct if V of D, that is the open circuit voltage, is greater than or equal to V of F. Actually, nakasulat na pala rito. I didn't have to write it. Ano ang V of D? Again, can I hear someone tell me what is V of D? Dito sa circuit na to. Anyone?
Sir, V of N din po.
Yeah, V of N, ano? V of N. Actually, if you look at this circuit, if you apply KVL, V of D is V of in minus V of out. No? Pero dahil open circuit ito, ang value ng V out natin is equal to 0. No? Okay? Ang value ng V out natin is equal to 0. So V of D is equal to V in. So when does the diode conduct? The diode conducts when V in is greater than or equal to V of F. Okay. That is when the diode conducts. When does that happen? So, drawing ko dito yung input. Kunwari ito yung V of F. Kunwari. V of F. Ito yung V of N. So, kailan nagko-conduct yung diode? Kailan mas malaki yung V of N sa V of F? Dito, sa part na to. No? Umpisa rito, hanggang dito, mas malaki yung V of E natin sa V of F. Tapos dito uli. No? So here, this is where the diode conducts. Ano? Itong from here to here. Here, the diode conducts. Okay, anong equivalent circuit niya pag nagko-conduct siya? Pag nagko-conduct siya, the equivalent circuit is a constant voltage drop. So this is V in. This is the equivalent circuit, V of F. So ano yung value ng V out? What is V out? Someone please shout it out. What is the value of V out?
Sir, V of in minus minus VF po.
Exactly, no? V of N minus V of F. So magki-KVL ka lang rito, makikita mo na V out is V of N minus V of F. So anong itsura niyan dito, no? Okay? Ang itsura niyan, yung graph natin na sinusoidal, parang bumaba siya. Bababa siya by the value V of F. No? So kung ito-drawing ko yan, it's going to look something like this. No? Ito ngayon yung V of N minus V of F. V out. Now, what about all other times? No? If V of N is less than V of F, excuse me, then this is an open circuit and V out is equal to 0. So this is how my output will look like now. So that is using the constant voltage drop model. So this is just explaining what we already did, no? So this is the equivalent circuit when Vn is greater than V of F. This is the equivalent circuit when Vn is less than V of F. and these are my outputs. Are there any questions? Okay, let's take up the full wave rectifier. Ano yung disadvantage ng half wave rectifier? Ang disadvantage ng half wave rectifier is you only have power being delivered by the source during the positive half cycles. Your source is only able to deliver power dito, tsaka dito, no? During the negative half cycles, walang pakinabang yung source. It's not able to deliver any power to the load. No? Now, what we want to happen in our rectifier is we want the source to be able to deliver power during both the positive half cycle and the negative half cycle. So yun yung pakay ng full wave rectifier. Trying to take advantage of the power delivery in both half cycles. Now, I'm going to start with a 2-diode, 2-source full wave rectifier. So this is a 2-diode, 2-source full wave rectifier. Okay, the one not yung isang pangit dito sa rectifier na to is kailangan natin ng dalawang supply, no? Okay. This is the not nice thing about this rectifier, no? That you need two supplies, V1 and V2. And V1 and V2 must be exactly equal. And when we say exactly equal, that means the same amplitude, the same frequency, and the same phase. What do we mean by the same phase? No, you're going to study phases in the later part of this course. Pero ibig lang sabihin yan, sabay na sabay yung dalawa. No? If this is V1 and V2, okay, sabay siyang umaakyat, sabay siyang bumababa. Sabay na sabay. No? Sabay siyang nagiging zero, sabay siyang nagiging maximum. So let's try to analyze this circuit assuming an ideal diode model. Okay. During the positive half cycle, ano nangyayari? No? During the positive half cycle, the current supplied by V1 tends to flow in this direction. And the current supplied by V2 also tends to flow in this direction. So napansin nyo, here the current supplied by V1 is in the same direction as the diode arrow. But here, the current supplied by V2 is opposite the direction of the diode arrow. Therefore, D1 is on and D2 is off. Okay, kung off yung D2, ibig sabihin open circuit to. Kung on yung D1, ibig sabihin short circuit ito. Okay. If this is equivalent to a short circuit, V out is just connected directly to V1. No? Notice V out is connected directly to V1. Whereas this is an open circuit, and therefore V out is not connected in any way to V2. Okay. So during the positive half cycle, V out is equal to V1. So ganun yan, no? Now, what happens during the negative half cycle? Okay, let me erase what I drew here. During the negative half cycle, ang direction ng current ngayon pag ganito, no? This way and this way. So napansin niyo ngayon, it is D1 that is off and D2 that is on, no? Kasi here it's tending to flow counterclockwise. So kung on yung D2, short circuit yan. This is an open circuit. Now take a look at how D2 is connected to V out, no? Yung positive terminal ng V2 is connected to the negative terminal of V out, and yung negative terminal ng V2 is connected to the positive terminal of V out. Meaning to say V out is the negative of V2. V out is the negative of D2. So ano yung magiging itsura ng V out kung ganon? No? Magiging itsura ng V out would be the negative of V2 pag ganito. Again, positive half cycle, it's equal to V1. Negative half cycle, it is the negative of V2. So that is your full wave rectifier. No? So looking at it more clearly here. So you can see that now you are delivering power both during the positive cycle and during the negative cycle. Okay, what if we had used the constant voltage drop model? Well, the analysis here is very similar to the half-wave rectifier, but we do it twice, one for the positive half cycle and the other for the negative half cycle. When does D1 conduct? D1 conducts when V1 is greater than or equal to V sub F, and our output is going to be V1 minus V sub F. Now, if you take a look, this output is equal to V1 minus V sub F. And we know that this is the equivalent circuit of the diode under these conditions when V1 is greater than or equal to V sub F. Again, that's based on the open circuit condition. You get the open circuit voltage. When does it conduct? When the open circuit voltage is greater than the forward voltage. And now you can replace it with its model. Okay, so you come up with this. Doon naman sa negative half cycle, when does the diode conduct? Okay, the diode will now conduct, what is this? No? When the open circuit voltage, so tanggalin natin to, kunin natin yung open circuit voltage, when V2 is less than minus V sub F. You can do a KVL here. No? You can do a KVL here, and you're going to validate this condition. No? That will happen when V2 is less than minus V sub F. So again, what will V out be? Okay, note that V out now is negative, right? So it's negative V sub 2 minus V sub F. If you try to do a KVL here, this is the equation that you're going to come out with. So this is this curve. Okay, notice that there's a certain period of time here that neither D1 nor D2 is conducting. No? So dito, neither D1 nor D2 is conducting. Dito sa mga periods na to. No? Okay. Is this bad? No? Is this value bad? Well, it depends really on what Vin is. No? Kung malaki naman yung Vin compared to V sub F, no? For silicon, V sub F is 0.7. Kung yung Vin natin is 220 volts, for example, halos hindi mo na makikita yung difference between the red curve and the blue curve. No? Pero kung maliit yung Vin, then of course you're going to see the difference between the blue curve and the red curve. Any questions so far? Any questions? Okay, saan natin kukunin yung source ng two-diode full-wave rectifier? So sabi natin, kailangan natin ng dalawang sources, eksakto at saka in phase, in the same frequency. Well, usually, nanggagaling yan sa transformer. No? So hindi pa nyo kinukuha yung transformer, kukunin nyo yan. That is the last topic of this course, transformers. I hope umabot tayo ron. No? So we're going to take this up in the future, but I'm sure you've heard, most of you have heard of what a transformer is. No? Kasi meron kayo yan sa mga bahay ninyo, I'm pretty sure. For example, kung yung bahay nyo, 220 volts lang, tapos meron kayong appliance na bili sa Japan o bili sa US. Japan, the voltage is 100 volts, US, it's 110. Then you need what is called a step-down transformer to transform from 220 to 110. Okay? On the other hand, if you have a low voltage, you want to step it up, then you can have a step up transformer. So a transformer, basically those are just two sets of windings. If your secondary winding, okay, don't be intimidated by the term, no? But if your secondary winding has a tap in the center, so we call this your center tap, then you can get two equal voltages, V1 and V2. And those two voltages will be in phase. So that's usually where you get V1 and V2. Okay. So that's all I'll say about the source for the meantime. Now you're going to understand this more when you study transformers. Okay, let's discuss the full wave bridge rectifier. So ang pangit dito sa rectifier na to, kailangan natin ng dalawang source. Okay? Merong paraan kung paano magkaroon ng full wave rectifier na isa lang yung source natin, Vn. And that's by using a bridge arrangement for your diodes. So this is what you call your bridge arrangement. But this time, instead of only 2 diodes, we need 4 diodes. Let's try to intuitively determine which diodes are conducting and which diodes are not conducting during both the positive half cycle and the negative half cycle. So let's take a look at the positive half cycle. The positive half cycle. Okay. During the positive half cycle, our current tends to flow this way, no? In the clockwise manner. Because your top terminal of the source would be positive with respect to the bottom terminal. Okay. You imagine your positive charge is flowing. Pagdating dito sa node na to, meron siyang dalawang option, no? Dito pupunta at saka dito pupunta. Hindi siya pupunta dito sa D1 dahil kontra yan sa D1 arrow. No, it cannot flow through D1 because that means that the current will be flowing from cathode to anode, which is not supported by a diode. So pagdating dito, your current is going to flow this way. Okay, pagdating dito sa point na to, hindi rin siya bababa rito dahil kontra sa D3 arrow. No? So mangyari, your current will flow here, will flow down the load, go back up here. Now what happens when it gets back up here? Will it go up? What do you think? Anyone? Aakyat ba yung current natin? Hindi na siya kontra sa arrow niyan, ano? It's already in the direction of the arrow. Will it go up or not? Can I hear someone? Somebody that hasn't talked?
No po, sir.
Yeah, explain why. Why?
Yung voltage po dun sa cathode po, mas mataas po kumpara sa anode.
That's right, no? Kasi ang direction of current flow is from higher potential to lower potential, no? In other words, kung nanggaling na yung current doon, ibig sabihin mas mataas yung potential na yon, no? So nanggaling na dito yung current, andito na siya. Pag bumalik siya diyan, it would need additional energy. But the diode is not a source of energy. The diode does not provide any energy. So hindi pwedeng umakyat yung current pabalik sa pinanggalingan niya, no, without any source of energy. Dito pwede, because Vin is a source of energy. So if you're here, you can go up there because Vin is a source of energy. But if you're here, D1 is not a source of energy, so you cannot go up there. Okay? So your current will go down here. Okay? So during the positive half cycle, we see that D2 and D4 are on. No? I'm just using that as a shortcut for conducting. and D1 and D3 are off. If we assume the ideal diode model, this is the equivalent circuit. And note that the positive terminal of Vin is connected to the positive terminal of Vout, and the negative terminal of Vin is connected to the negative terminal of Vout. In other words, Vout is equal to Vin. Okay, tignan ngayon natin yung negative cycle. No? Let's look at the negative cycle. In the negative cycle, the current tends to flow in this direction, no? In the counterclockwise direction. So again, let's try to intuitively determine where the current will flow. No? Pagdating dito, kontra siya sa D4, so aakyat siya dito. Pagdating dito, kontra siya sa D2, so pupunta siya dito. Okay. Babalik siya dito. And then for the same reason earlier, from here, it will not go down because that is of higher potential. So it has only choice is for it to go up and then back to the positive terminal. So during the negative half cycle, you see that D3 and D1 are on. Okay. On the other hand, D2 and D4 are off. And this is our equivalent circuit. Okay, take note now, no? Yung positive terminal ng Vin is connected to the negative terminal of Vout, no? And the negative terminal of Vin is connected to the positive terminal of Vout. Meaning to say Vout is equal to minus Vin. Ito yung input, ito yung output, bumaliktad ng gano'n, ano? Bumaliktad. Okay, so you can see, no, yung full wave rectifier, pag positive half cycle, yung input at saka output pa ganyan, no? Pag negative half cycle, bumabaliktad yung isa. Okay? Positive half cycle, negative half cycle, positive half cycle, negative half cycle. That's how you can imagine the full wave rectifier operating. So, what will the output look like? Okay? Positive half cycle, nakakabit siya. Negative half cycle, bumaliktad, ito bumaliktad, nakakabit pa rin siya. Parang positive. And we were able to do that with only one input. But then we had to use 4 diodes. Okay, the full wave bridge rectifier, we also call it an absolute value circuit. Take note that this is the absolute value of this. Ano yung absolute value? No? When the input is positive, the output is positive. When the input is negative, the output is the negative of the input, which will make it again positive. And that has some practical applications, not only in rectification. For example, if I had an electronic device na DC, battery operated, and maselang yung device na yun, ano, na pag binaliktad ko yung baterya, masisira yung device. Well, the designer might want to put in a protection na kahit na anong kabit mo ng baterya, tama pa rin yung polarity ng voltage na makikita ng circuit sa loob. So one thing you can put is a full wave bridge rectifier. Because the full wave bridge rectifier, no matter what the polarity of your input, your output will always be of the correct polarity. Okay, so that's one of the practical uses of a full wave bridge rectifier na hindi rectifier yung ginagawa. No? It's more a polarity corrector. Okay, now, what will the full wave bridge rectifier look like if we use the constant voltage drop model? Okay, to determine whether the diode will conduct, we can use method 2. You get the open circuit voltage. But this time you have two open circuit voltages. So if I want to determine whether the diode will conduct, dalawa yung open circuit voltage ko, no? So this is one open circuit voltage. This is my load. Okay. And then I have another open circuit voltage here, no? Sorry, mali yung drawing. Then I have another open circuit voltage here. Okay. So this is R, this is V out. How do I know that? When will these diodes conduct? No? For these diodes to conduct, the open circuit voltage here should be greater than V sub F. And the open circuit voltage here should also be greater than V sub F. In other words, the open circuit voltage across these two open circuits should be greater than 2 V sub F. Medyo mahirap pakinggan, ano? The open circuit voltage across these two open circuits together should be greater than 2 times V sub F. And this is going to be my equivalent circuit now. No? As long as it's greater than 2 V sub F, then I can replace D2 with V sub F, and I can also replace D4 with V sub F. My output, take a look at my output. If I apply KVL to this loop here, my output is just going to be my input minus 2 times V sub F. So that's what it will look like. Let me erase the pen markings. During the positive half cycle. Now, during the negative half cycle, ganun din, my diode will not conduct unless my input is less than, this time, the negative of 2 V sub F, no? Kasi ang input ko ngayon, baliktad yung polarity, okay? So that the diode will only conduct when the input voltage is less than negative 2 times V sub F. And my output will be the negative of V in plus 2 V sub F. So you can do that analysis easily by applying Kirchhoff's voltage law to this particular loop, adding all of the voltages. You're going to see that this is correct. Now note, there will be a region where the diode does not conduct, just like in the two diode full wave. In the two diode full wave, it doesn't conduct when Vin is greater than negative V sub F and is less than V sub F. Now it's twice that, greater than minus 2 V sub F and less than 2 V sub F. Anyway, so this is going to be how my output will look like. So ito yung sinasabi kong region na hindi siya magko-conduct. Let me use different color. Here, there is no conduction. And notice now, our output is shifted down by 2 V sub F. And the region of conduction is when V sub N is greater than 2 V sub F in the positive, and in the negative, V sub N is greater than 2 V sub F. Okay. That's when it will not. That is when the diodes will conduct. So you can see the disadvantage of the full wave bridge. Medyo malaki yung difference between the input and the output. It's twice what it would have been if it were a 2-diode full wave rectifier. But the big advantage is you only need one supply. So nowadays, usually hindi na talaga ginagamit yung two diode full wave rectifier dahil medyo malaki yung transformer eh. A transformer is a little bit bulky, and so you hardly see the two diode bridge full wave, yeah, the two diode full wave rectifier. You hardly see that used nowadays. Okay. Nowadays, if you notice the power supplies, for example, of your chargers, they're very, very light. No? Meaning to say there's no transformer inside. Yung mga sinaunang power supply, medyo mabigat-bigat pa. Kasi may transformer sa loob yun. So, mas madalas talagang gamitin ngayon sa mga rectification applications ang full wave bridge. Are there any questions with regard to the rectifier? Okay, I'm going to move to the clipper. This is a positive clipper, or we also call it a limiting circuit. Now, what is the function of this particular circuit? No? A clipper establishes a maximum level that your output voltage can attain. So this clipper, okay, establishes a maximum value for the output. Okay, now what component here, okay, dictates that value? That will be dictated by V of X. No? So V of X dictates the value. Okay, when will your diode conduct? When will this conduct? Again, let's use method 2. So let me redraw this. Let's use method 2. So method 2, ibig sabihin, kunin natin yung open circuit voltage. Okay, so this is now V out. So this is plus minus V of D. No? When will the diode conduct? The diode will conduct if V of D is greater than V of F. If ideal, it conducts when V of D is greater than 0. Remember, I mentioned earlier, an ideal diode can be considered as an ideal diode. You can think of it as V of F just being equal to 0. But what is V of D here? Okay, who can tell me what V of D is here? Anyone? All you have to do is do a KVL here. Ano yung value ng V of D? Actually, nandyan na sa slide actually. No? Okay. I guess people are a little lethargic this afternoon. No? V of D is just V in minus V of X. No? Wala kang voltage drop dito dahil open circuit to. So V of D is just V in minus V of X. So the diode will conduct when V in minus V of X is greater than or equal to 0. No? Dahil dito sa condition na to. When V in minus V of X is greater than or equal to 0, or V in is greater than or equal to V of X. So dito nagko-conduct yung diode. No? When V in is greater than V of X. Okay, when the diode is conducting, it's equivalent to a short. And if it is a short, V out is equal to V of X. That's why this is your output when the diode is conducting. So yun, tinabas niya yung input, ano? Tinabasan niya yung input, ayaw niyang lumampas sa V of X yung input natin. That's why you call it a clipper or a limiter. It clips the value at V of X. Okay, what happens all the other times? All the other times, your diode is not conducting, and therefore it's equivalent to an open circuit. If it's equivalent to an open circuit, then your output will just be equal to your input. So that's what it shows here. Okay, what will happen kung baliktarin ko yung diode at saka baliktarin ko yung piece of X? So it now becomes a negative clipper. In this case, it establishes the minimum value that your input can have. It will not allow your input to have a value smaller than that minimum value. And that is established, or that is set by V of Y. No? So V of Y sets the minimum value of the output. And you perform the same type of analysis. When does the diode conduct? Open circuit yan. This time your polarity for V of D will be this way. Okay, this is V of Y. Your diode conducts when V of D, but V of D is what? V of D is minus V of Y minus V of in. No? And that should be greater than or equal to P of F. If it is ideal, that should be greater than or equal to 0. So ito yun, no? Minus V of Y minus V of in should be greater than or equal to 0, or V in is less than or equal to negative of V of Y. And when your diode conducts, this is equivalent to a short circuit, and your output will just be negative V of Y. Negative dahil sa polarity, you know? This is plus minus, ito naman plus minus dyan. Kaya negative. And everywhere else, your output is equal to your input. And you can combine the two, and you're going to get a positive and negative clipper. So positive clipper, dito negative clipper. Okay, let me go back to the positive clipper. What if I did not use the ideal diode model? What do you expect the curve to look like? Anong magiging itsura ng curve kung hindi natin ginamit yung ideal diode model? Anyone? Any ideas? Any brave soul there that wishes to take a chance at an answer?
Hindi po, sir. Madagdagan po siguro yung max value.
Exactly. Very good, no? Madadagdagan yung max value. Kasi, sige, let's do it here, ano? So kung hindi siya ideal, okay, ito yung input natin. Okay. Okay. When will the diode conduct? The diode conducts when V in, this is V in, when V in minus Vx, yan yung open circuit voltage across the diode terminals, no? Vin minus Vx is greater than Vf, or Vin is greater than or equal to V of x plus V of f. And your equivalent circuit is going to be like this. Ito yung V f natin, ito yung V of x natin. This is equivalent circuit. So what is V out? V out will just be V of x plus V of f. No? So kung ito yung input natin, ito yung V of x plus V of f. Dito siya magkiklip. Diyan siya magkiklip. So madadagdagan yung level at which you make your input clip. Ganon din dun sa negative clipper. Okay. So those are the only two types of circuits that we're going to discuss in this course. No? There are many other practical diode circuits, but a lot of them you would have to know about capacitors before we can actually discuss them. So you're going to take up these circuits in your next course, no? In EEE123W6L2THX, no? After you've had the chance to familiarize with capacitors or even inductors. Okay. Any questions? Any questions? That's all, no? So let me do it as I've been doing it the past few times. If there are questions, I'll stick around. I will not close the session until everybody has gone. So in case you want to stick around and ask me questions, I will be here until everybody is gone. Okay. By the way, this actually is a repeat of a pre-recorded lecture that I published, no, dun sa study guide. Kung binasa niyo yung study guide, meron ng lecture na ganito. So in effect, you listen to the same lecture twice. At this point, after mastering the subject matter, I encourage you to try the second set of practice problems, yung practice problem set 2. If you've done practice problem set 1 and 2, you're ready now to take the quiz. So go ahead and take the quiz. The quiz was already released. We discussed among ourselves, no, yung mga handlers, and we decided to give some concession to the students. So dati the quiz is open on Wednesdays. It will close on Saturdays. So we decided we'll give you 1 week to do the quiz. No? So it's going to be from Wednesday to Wednesday. And then sabi din namin, okay, we're going to also release the problem sets earlier and give you 2 weeks. So take a look at the problem set. You can already look at the problem sets so that you have an idea of what the level of difficulty of the problem set is. No? And you have two weeks to submit the problem set. But if I were you, I will not make use of all the 2 weeks. Kasi ang ayaw nyo mangyari is nag-overlap yung mga requirements ninyo. No? One of the reasons why we wanted a stricter deadlines is we wanted you to avoid having your requirements overlapping. So now you have more flexibility, but if you don't do things right away, then you might end up having overlapping requirements. Kayo rin mahihirapan. So try not to make that happen. No? In other words, try to attend to the requirements as quickly as you can. Okay. So that's the end of diodes. The first electronic device that you're introduced to. So next week will be transistors. It's going to become more exciting next week. Okay, thank you. I'll stick around. Thank you.